6. Do people want to see some LLVM stuff, or do we want to jump into the paper?
Paper.
That was a quick shot down in the road.
Yeah, that was like.
Okay.
I mean, you asked your answer, right?
Yeah. Well, I was going to throw it to a vote, but you know, if we want to have a benevolent dictatorship, we can.
No.
By the Russian.
Mine.
I'm okay with that. Yeah.
But are people interested in seeing just maybe a little bit of LLVM workflow stuff?
Is it related to assignment number 3?
Yeah.
Highly?
It might even be more related to.
Then yeah, totally. It's very important. I haven't even started.
I applaud your honesty. Okay, that's okay.
I guess all of you for workload. Yeah. That's workload was good.
That's okay. So we'll just take a few minutes of your time for this one, and then we'll jump into the paper presentation. And hopefully the 3 of you who actually did critique this, 2 of you who are here, found the paper interesting.
I actually really like the. I'm going to copy their way of doing the results demonstration. And how they presented their results. It was very, very clear. Very nice.
We can come back to that. We can come back to that.
No?
I don't think so.
Oh, at least their diagram was clear.
No, all the results, no.
Oh,
Saying
okay.
that.
Yeah, well, I mean, I think there was some confusion, but various sources of confusion may have been to misinterpretation and various things of that nature. It happens.
Maybe I just misunderstood.
No.
So far that I thought it was clear.
I actually thought they were clear as well, but they were open to misinterpretation. Okay. So.
No one gave them their results to test against. Everyone refused.
That's
the point.
Oh, right, this. Yeah.
HDMI.
Right, exactly. Okay. Same as. Hello, VGA.
And neither works.
Bye-bye,
Yay.
Oh, come on. Yes! Okay. First time.
Same thing.
Yeah.
Yay, we get the projector working after a
God,
couple weeks.
is this such an achievement?
You say first time, but it's been how many weeks?
First time I've tried in quite some time.
Okay.
What did it change?
I'll take it, I'll take it. Don't
At least the projector didn't turn off.
Don't be a hater.
True.
Yeah.
What
Okay.
changed?
So what changed? I used the right command because I was awake. That's basically what changed. Okay,
Like this, please.
so in terms of, let me not kneel because that's kind of painful. In terms of the project, one of the things that you have to do is figure out how to add code to something, right? And one of the big issues that people have faced is just figuring out
How to compile?
Step 1, how to compile, and step 2, how to actually add code to something. And as was astutely pointed out in some emails and referenced back to slides on the second day of class, I gave you some helpful hints that maybe weren't as clearly highlighted as they could have been in terms of saying, this will help you a lot. So let's start off. Let me just go into temp, so this is all nicely throwaway stuff. And let's make a nice little directory to keep things clean. Happy little directories. Okay, let's say that we want to do something, that we want to insert some code into a program. It could be code that does anything at all. The easiest way to figure out what this code is, logically, like in our heads, is to write it in a C program first, right? Before we try to figure out how do I inject this code into a program, we can start off by saying, I'll just write a C program that does the same thing. So let's do that. Let's make a small bit of code that does something. What do we want to do? Any suggestions?
Hello world.
Hmm?
Hello world.
We could do hello world. That's actually more complex than you might want because it involves things like strings, which are ugly. And yeah, that sounds like that shouldn't be too complex, but it's messier. As you saw, if you looked at the generate function table function of the demo, right? That involves strings, and that's ugly. And your stuff is simpler than that. But we could do something simple. Let's say that we want to.
The counter that increments every time.
Okay, we could just increment a counter. Yeah. So let's say that we've got some global counter, and it's going to initialize to 0 because it's nicely global. And we're going to see what we want to do to increment this, right? So let's say we have void foo, and if all we're actually going to do is increment this, I guess that's it, right? This is the sum total of our instrumentation.
Should that be 0 first?
It's a global, so it's automatically initialized to 0. Right?
I didn't know that.
Learn something new every day. Okay. So, first thing we can do is compile this to bitcode. C, and I'm going to make this look ugly first. Well, it's small, but it'll still look kind of ugly. We'll say emit LLVM -o foo.bc, and that's actually, let's generate assembly. Oh, let's generate assembly. So foo.ll. Okay. Okay.
Instead of doing LLVM diff.
Oh yeah. It works with GCC too.
I'm learning.
Okay, so we run clang, and now we can open foo.ll, and this gives us our little function here. And we can see we're loading my counter, we're adding to it, and then we're storing back to my counter, right? Okay, that's reasonable enough. And this tells you exactly what you'd want, essentially the logical instructions you'd want to do. If we could somehow insert this assembly into the program, we'd be set, right? If we wanted to just add a counter somewhere. So how do we translate this into API calls? And this is where the helpful little hints from the slides comes into play, right? We say LLC -mrch equals CPP, and we can say foo.ll -o foo API.cpp. And what this will give us is the LLVM API calls to create those exact instructions if we wanted to insert them inside a program. So let's see. Yeah, nice, right? Okay, so a lot of this is garbage, right? Most of this is tough to read. It generates a program that will generate that program. So you can see here's main, and it makes a module inside this main method, and that module we make is foo.ll. Right? So it's all of the API calls necessary to make that thing we compiled.
So what this program will do is invoke LLVM, read in the file, the LL file, create.
It won't read the LL file at all. What it does is use the LLVM library to construct a new empty module, construct a new global variable in that module, construct a function called foo that is a void and takes no arguments, and add a single basic block to that function, and then add a read of a global variable, an increment, and then a store of that global variable inside the function. So it starts from scratch and creates a new module.
So basically, it turned our code into a module that you can do.
Well, it looked at the module. It looked at foo.ll, and it said, and it creates a new program, that can construct foo.ll using the LLVM API.
So we don't use this code directly. We look at
You
this
look for
as-
what's interesting. This is a template which tells you, okay, you wanted to do something, here's how you can do it. It also includes things that are more complex than you want. So for instance, here we're making a new module, foo.ll, which has certain properties you don't necessarily care about, but you're making a new module, and it shows you if there are types inside this module that you didn't understand. Like for instance, we need to have some sort of pointer to an integer, because that's what a global variable actually is. So it shows how to construct those types. So if you need to manipulate something, say a complex type like a struct, it'll show you how to create that type using the LLVM API, which is how I created that function table in the demo.
Okay.
I used this to generate the struct type for me automatically,
Mhm.
and then I simplified it. I went back afterward and I simplified it. We'll talk about that in a moment. So 5 more minutes. We'll finish in 5 more minutes. Which I always end up saying, but we should hold me to that. We should hold me to that. Okay. So you can see down here now we're creating a function type, which is essentially the prototype of a function. Sans the actual name, but it's the return type and the argument types, right? And then down here, you can see a whole bunch of extra stuff. In general, you can cut these things out. When you look at setting calling conventions, when you look at things like attributes of things, ignore all of that. That isn't relevant to what you're interested in. Once we get through all of this construction of a global variable up there, right, that's where we actually create my counter. You can see?
Yeah.
We then have some constants, right? We have a constant 0 and a constant 1. Constant 1 is what we're adding to the global variable. What's the constant 0? What it gets initialized to, exactly, because the initialization is explicit in here. It was implicit in the C code, but the semantics of C define that a global is initialized to 0. So that's set in here. Okay. And then down here, we create a basic block. We add a load instruction. It shows you that if you want to load a global variable, you need a load instruction. It shows that we need a binary operator that is an add. So aha, if you were thinking before, there's no add instruction. How do I create an add? Now you see, you create a binary operator. It shows you what you need. And it shows you that the binary operator you want is an add. And then it shows you a store instruction. Okay. And that's the entire thing. Like this down here, these are the instructions for the function. And if you only wanted to know, how do I create these instructions to add them to a module, you just look at this. Now it's a little more complicated than that, in general. Why? Well, let's take a look. So let's open foo.c. Let's say that I want to add something conditional in here. Let's say if my counter is less than 10, because I want to threshold this for some reason. Then I'll increase it, right? And maybe otherwise, I will do something else. What will I do otherwise? I'll add to a different counter. So very much on the fly, as you can tell. Not really planned, but we'll work through it. Feel a little bit like Bob Ross. Need an afro, that's okay. Which, I don't know if any of you will get that reference, which is unfortunate. Bob Ross, look him up on YouTube. Painter.
Yeah.
Fun.
Little trees.
Yeah, happy little trees. Happy little trees, that's right. Okay. Not exactly an international reference, usually. But anyway, very relaxing. Okay, so I've changed that program. Now, if I compile it, let's look at foo.ll and see what it contains. Well, it contains some loads and stores up here. Well, it contains a load up here, contains a load and a store here, and it contains a load and a store here. Maybe we don't need all of those loads and stores. So if there are some of these extra operations we don't need, we can get rid of them by just compiling with optimization. So whenever you do this, compile with optimizations enabled, and it'll get rid of the extra instructions, right? This should seem, maybe that sounds stupid.
Yeah,
But-
we hope that your program remains.
Well, in general, if there are things that I want to remain, let's,
My experience with optimizations is
this is a function, right? If there's anything that I want to force to remain, this function can be called from outside of what's compiled. I just add the things that I want to force to be there as arguments to the function.
Okay.
And then I can't optimize them away.
Okay, yeah.
Simple enough trick?
Yeah.
Okay, okay. Yeah, and there are these little things. It's a good thing to actually point that out, because these are the little tricks that are helpful.
You should have written O2.
O2, yeah.
Zero.
No, that's O2, otherwise it wouldn't compile. Yeah, so I believe with this font, it should actually, there we go. A 0 should have a dot in it. So, helpful little things. Good programmer font. Anyway, so we compile that. We look at foo.ll. Now notice we only have a store here, we don't have the extra load. So it gets rid of the extra instructions, it's less stuff to do, it makes it look cleaner. That might seem stupid for this example. If you do anything more complex than this, it becomes a lot less stupid. Because the fewer instructions you have, the easier it is to understand. Okay, and in addition, after I post-process things, usually I come over to the IR Builder class. So here's irbuilder.h. And if we look in here, address space, don't want that. This is a helper that lets you do things like, oh, you want to create an add function? There's a method just for creating an add function. You want to call a function with 1 argument, a function with 2 arguments? There are methods created just for that to make everything easier. What happens when you use this class is that complex behaviors with multiple instructions become legible. So this is something from a previous research project of mine, and this is legible. So we have here create a 0 extend, which means take a small integer and make it larger. Get a constant 64-bit integer with the value of 32. Perform a left shift based on a given size. I guess that was a 32. And then we're creating another 0 extend, and we're creating an OR. And so I have this set of instructions, and I can actually read what they are, instead of, here's create new something or other, and whatnot.
Hold on, what was the path to get here? Like, what do you, I missed?
The IR Builder API.
Okay.
So there are methods for basically everything you want to do inside this class.
Yeah.
And if you use them, you get something that looks like this.
Oh, yeah.
So, you know, we saw before that you'd create a new binary operator to do an add, right?
Mm-hmm.
Instead of creating a new binary operator, which mixes allocation and long names, and the fact that it's a binary operator and not an add, now there's just a function, for any of these things, we have like create shift, right? Create shift left. That would normally be a binary operator. And now it's something that's easy to read, for me at least. And I can look at this, everything is nicely aligned, and it makes sense to me. And eventually it makes sense to you as well. So you can post-process these things and things look clear. Okay, I think I've taken up enough of your time. People maybe feel more comfortable that you can actually do legible things to add instructions to programs. At least some more stuff to explore that I pointed you at in the beginning of the semester, but maybe I didn't point hard enough. Okay? Okay. So with that we can move back on to
I will just quickly restart the video so we will have
Okay.
video.
Do you need